Right, this recording is to help you with the lesson on parametric equations, part 1. Okay, so the first thing we're going to talk about is parametric equations are dealing with x equals and y equals, and now your variable is actually t. Okay, so x and y are your dependent variables. Your independent variable is now your t. So basically what we're going to do is we're going to choose values for t and then plug them into our equations to get our ordered pairs for, or to get our values for x and y, and then we're going to look at those as our ordered pairs. So here I have x equals the square root of t and y equals 1 minus t. So let's just choose some values for t here, and they gave us 0 through 4. And let's start with just filling in the chart for x. So when I plug 0 in for x equals the square root of t, I get the square root of 0, which is just 0. The square root of 1 is 1. Then I get the square root of 2, the square root of 3, and the square root of 4, which I can simplify to 2. Then to fill in my chart for y, I plug 0 in for t. So 1 minus 0 is 1. 1 minus 1 is 0. 1 minus 2 is negative 1, 1 minus 3 is negative 2, and 1 minus 4 is negative 3. Now what we do to sketch our graph then is we look at the x, y as an ordered pair. So I can start by plotting the point 0, 1. And then I can plot the point 1, 0, square root of 2, negative 1, square root of 3, negative 2, 2, negative 3. And then you can just connect your points to see your graph. Okay, we can also change our parametric equations into a rectangular equation by using substitution. So what we would have to do is we would have to solve for t in your first equation for x equals. Okay? So what we're going to do is we're going to solve for t here. So I would start by adding 1 to both sides and then dividing by 3. So t equals x plus 1 all over 3. And then we're going to substitute that into our second equation. So what happens is we'll get y equals 2 times x plus 1 over 3 plus 1. And notice now this is our rectangular equation because we're dealing with just x and y. So that's kind of nice. What we can do is we can simplify this if we need to. I can divide kind of everything by 1. Well, I should probably distribute the 2 first. 2/3 x plus 2/3 plus 1. I can technically make this 2/3 plus 1 is 5/3. And if I want to, I can leave it like that and then graph it. And we can see that that, in fact, is the line we get here. Or you can go ahead and multiply everything by 3 to get rid of your fractions, but that won't help with your graphing part of it. So here is the line that we can graph in rectangular coordinates. So all we have to do to go from parametric to rectangular is using substitution. Okay, we can also graph in parametric mode, or we can graph parametric equations on our graphing calculator. It does take a couple steps here that we need to change, so let me bring up my graphing calculator and show you this. Right, so right now we're actually working in parametric equations. So what we need to do is we need to make sure we are in parametric mode. Okay, we can also do this when we're talking about polar equations. We can go work in polar mode. But right now, we need to make sure that we are in fact on radian. If radian is not selected here, it will take forever to get a graph where you can finally get out of and then go and change your mode. So please make sure that you are in radian mode. Okay? And of course, instead of function, we want to switch over and make sure the PAR, which stands for parametric, is selected. You can probably guess that POL stands for polar, but that's coming up. Right now we're just focusing on our parametric. So we do want to make sure that that is selected there. So when we go into, go to graph, we now see that x equals and y equals. So now we can plug in our equation. So in the example that I was working on, we had x equals 4 plus 2 cosine of theta. And to represent your theta, you're just hitting that xt theta n button. Now theta does not pop up, a t pops up, that's perfectly okay. And then we'll enter the y equation here of -1 plus sine of theta. And then we'll hit graph. Okay, now you might have to zoom in or adjust your window to see it, but we do get what looks kind of like an oval or an ellipse there for our graph. And let's see if that actually does match up with what we're given. Again, look at where it's positioned, because when we go back to the whiteboard here, you notice that it does line up there. Okay. Notice that they have little arrows on here. It does matter which direction the graph is sketched in. Okay, so it does make a difference that it's being graphed in a counterclockwise direction. And we can tell that when we go back here on our calculator. Just watch and pay attention to what direction it's actually sketching your graph in. Okay, so watch very carefully because it's going to go quickly, but you should know that it's being sketched in a counterclockwise position. And we did notice that. Okay, so it does matter. We should actually put those little arrows in there to indicate that. And you can see them there. Okay, the next one again is just graphing to see what type of curve you have. I'm not even going to attempt the name of this curve. I'm not very good with those names. So again, we're going to go back to our graphing calculator and type these equations in, and hopefully it'll see what looks like an infinity sign or an infinity symbol. Okay, so our first equation was 2 cosine of theta. Our second equation was sine of 2 theta. And when we graph it, there is our infinity.